Okay, I wanted to do a little electronics demonstration here. Now, a while back, I showed that this copper film or copper tape that you can get from Studio Pro, which is usually used for stained glass foiling tape, I showed that you could indeed run a circuit across this if there was zero resistance. Now, I said at the time that I was going to go ahead and try to see if this would hold solder. Well, I just did that, and yes, indeed, it does hold solder. In fact, if you tin your wires first and put your wires on the copper and then touch it with your soldering iron, it will almost immediately solder together, and then when you remove your soldering iron, it will hold its shape. Now, to prove this, and to prove that it conducts electricity, I've hooked up my volt ohm meter, and as you can see, there is zero resistance. Now, if I remove one of these, I've taped it temporarily to the counter, you can see you've got an open. So clearly, this film does conduct electricity and can be used in tight spots like the Enterprise D or the refit from Polar Lights, or even the Reliant from AMT/Polar Lights, whatever. Additionally, I wanted to tell you, in case you didn't know, brass is an alloy of copper. It's a mixture of copper and zinc in varying rates. So this brass shim stock, or brass material that can be used for etching small patterns, has zero resistance across it as well at short distances. It's almost, but not quite as conductive as copper wire. So you can use this in tight spots for long sections, like in the pylons of the pylons going to the nacelles on the Polar Lights Enterprise. You can cut thin strips of brass, solder your wires to each end, just as I've done here, only with the brass, and you've got a conductor for running your electronics, and you don't have to have a Dremel to drill out an area at the bottom where the pylon meets the engineering hall. So, once again, Electronics 101. Woohoo! Okay, I wanted to do a little electronics demonstration here. Now, a while back, I showed that this copper film or copper tape that you can get from Studio Pro, which is usually used for stained glass foiling tape, I showed that you could indeed run a circuit across this if there was zero resistance. Now, I said at the time that I was going to go ahead and try to see if this would hold solder. Well, I just did that, and yes, indeed, it does hold solder. In fact, if you tin your wires first and put your wires on the copper and then touch it with your soldering iron, it will almost immediately solder together, and then when you remove your soldering iron, it will hold its shape. Now, to prove this, and to prove that it conducts electricity, I've hooked up my volt ohm meter, and as you can see, there is zero resistance. Now, if I remove one of these, I've taped it temporarily to the counter, you can see you've got an open. So clearly, this film does conduct electricity and can be used in tight spots like the Enterprise D or the refit from Polar Lights, or even the Reliant from AMT/Polar Lights, whatever. Additionally, I wanted to tell you, in case you didn't know, brass is an alloy of copper. It's a mixture of copper and zinc in varying rates. So this brass shim stock, or brass material that can be used for etching small patterns, has zero resistance across it as well at short distances. It's almost, but not quite as conductive as copper wire. So you can use this in tight spots for long sections, like in the pylons of the pylons going to the nacelles on the Polar Lights Enterprise. You can cut thin strips of brass, solder your wires to each end, just as I've done here, only with the brass, and you've got a conductor for running your electronics, and you don't have to have a Dremel to drill out an area at the bottom where the pylon meets the engineering hall. So, once again, Electronics 101. Woohoo! Okay, I wanted to do a little electronics demonstration here. Now, a while back, I showed that this copper film or copper tape that you can get from Studio Pro, which is usually used for stained glass foiling tape, I showed that you could indeed run a circuit across this if there was zero resistance. Now, I said at the time that I was going to go ahead and try to see if this would hold solder. Well, I just did that, and yes, indeed, it does hold solder. In fact, if you tin your wires first and put your wires on the copper and then touch it with your soldering iron, it will almost immediately solder together, and then when you remove your soldering iron, it will hold its shape. Now, to prove this, and to prove that it conducts electricity, I've hooked up my volt ohm meter, and as you can see, there is zero resistance. Now, if I remove one of these, I've taped it temporarily to the counter, you can see you've got an open. So clearly, this film does conduct electricity and can be used in tight spots like the Enterprise D or the refit from Polar Lights, or even the Reliant from AMT/Polar Lights, whatever. Additionally, I wanted to tell you, in case you didn't know, brass is an alloy of copper. It's a mixture of copper and zinc in varying rates. So this brass shim stock, or brass material that can be used for etching small patterns, has zero resistance across it as well at short distances. It's almost, but not quite as conductive as copper wire. So you can use this in tight spots for long sections, like in the pylons of the pylons going to the nacelles on the Polar Lights Enterprise. You can cut thin strips of brass, solder your wires to each end, just as I've done here, only with the brass, and you've got a conductor for running your electronics, and you don't have to have a Dremel to drill out an area at the bottom where the pylon meets the engineering hall. So, once again, Electronics 101. Woohoo! Here's the lower sensor dome for the lower primary hull of the 350 refit Polar Lights kit. Now, I wanted to show a couple of tips and tricks on this one thing real quick. I'm getting ready to install this after I add the LEDs that go in here and finish blocking the light on the forward section. Now what I did is I took strips of large fiber optic and glued them into place to direct light. As you can see here, I've got a fiber optic here. There was a fiber optic here, but it came loose. I'm going to have to re-glue it. Fiber optic here and fiber optic here. Now this is just to make sure that the light comes out exactly where I want it when I put the super bright white LED here. You also have to remove the front tab and clean it up in order to get a good solid super bright white light right here, so that it points out in the direction that you want it underneath. Now the left and right are not quite as important, but they are almost. The rear, on the other hand, isn't nearly important, but you still want to try to direct light wherever you can with these fiber optic pieces. Now I'm going to re-glue a couple that are missing, but I wanted to show this. Additionally, if you take an X-Acto where this meets on the lower primary hull and core it out a little bit on each one of these tab areas on the lower primary hull, it's easier to place the lower sensor dome, and it's easier to block the light. Now I won't be able to show you, but what I'm going to do is I'm going to clean off some meat all around each section where it mates up with the lower primary hull on the back end of this, so that I get a good clean seal all the way around. There's also going to take a little bit of sanding of these windows, or these areas of the lower sensor dome where the light shines through, so you get a good clean seal. Now when I'm ready to, when the LEDs are in place and everything's ready to glue, what I'm going to do is I'm going to backfill this with some putty everywhere there's a connection except where the windows are, and I'm going to make sure that there's just enough buildup of putty around here so that when I press it down firmly and glue it into place, there will be no light leak, and there will be no seam, or no apparent seam, and no gap. So there's a little trick on the Polar Lights lower sensor dome. This is a 555 timer circuit. This is timed exactly to the lighting sequence for the flasher on the refit Enterprise. Therefore, this one circuit is going to be used multiple times in Lance's refit, the 1/20th scale refit bridge and BC deck, and the 240 scale refit, which is 1/2 studio scale, 50 inches long. Same circuit. The 555 timer and an RC time constant is the basis for all of these flasher circuits. One single chip. Additionally, for multiple outputs, the 555 timer, in conjunction with the 4017 clock timer divider sequencer chip, is the basis for many multiple flashing circuits and circuits that flash in sequence, i.e. the spinnies on the original series Enterprise circuit that I'm working on, flasher circuits, and it all goes down to timing and 2 chips. So it's really not rocket science. When you've got a background in electrical engineering, this is basic stuff 101. I built this circuit. This is my breadboard, my parts. I just want to make sure you know that everybody knows that this was designed and timed specifically by my friend Big Jim Slade. He sat down and took the time to do a step-by-step, frame-by-frame timing sequence, and this is what he came up with. There's only a slight variation on this circuit for the original series timing circuit, so I'm going to be using almost exactly the same circuit with a minor variation for the flashers, nav lights, and anti-collision lights on both the 350 refit and the 350 original series. So there you go. I will post this circuit for free online to anyone who wants it. Now here's the 1/20th scale refit bridge and BC deck that we've just about got ready to go into production. I've got to drill out a couple of holes here that got filled in during the prototyping process. I've got to do just a little more cleanup. Currently John is working on an interior and I'm working on an interior, but we should have this done and ready to go into production before Christmas. It's already 99% done. I got a couple of minor things to do, and this is good to go and ready to go into silicone. And this is an almost exact duplicate of the studio scale bridge and BC deck that was used in the film. All I've got to do is hook up my little timing circuit, throw some LEDs in here, and we've got a light test. Woohoo! Alright, about lighting this kit. We've already taken steps to make this easy to light. As you can see, all around here, you've already got pre-drilled holes for 3mm super bright white LEDs. You've also got a 3mm hole for the blinky LED, the anti-collision light, flasher, whatever you want to call it. Now, sometimes, if you've seen in some guys' models, as soon as the flasher flashes, all the interior lights seem to get brighter. That's because the circuit isn't isolated. So part of isolating the circuit is isolating the flasher circuit electronically from the rest of the circuit, and isolating the light from the rest of the circuit, so you don't see a pulse in light in, say, the bay windows or the officer's lounge or what have you. That's where this comes in. This is nothing more than a wire wrapped or heat shrinked LED that's already pre-wired, so I can isolate it optically from the rest of the lights. We'll get to isolating an LED or flasher circuit from the rest of the primary lighting circuit in another video. Sorry, can't cover everything, and I've got plenty of video. Here's Lance's lower primary hull. I've been working on this off and on for 2 days. Between the lower primary hull and the lower sensor array, I've been working on this for a couple of days off and on. I've got a light block at the front, as I said earlier. Everything else is light blocked. I'm going to go over everything, do some cleanup, and then do some more light blocking. I've got one super bright 3mm LED in place for the forward light. And what I'm going to do is I'm going to put this in place, make sure that it's perfectly sealed, that there are no light leaks underneath the lower primary hull. Then through the top, I'm going to pour some 2-part binary epoxy resin clear cast into the bowl after this is secure, and I'm going to insert and embed in the clear cast some super bright white LEDs. This circuit for the lower sensor dome is going to be isolated from the primary hull. It's going to be on its own separate circuit. Additionally, the lights inside the primary hull are going to be on a separate circuit. The light in the bridge, or the lights that show on the bridge, are going to be a separate circuit. And there's going to be an isolated flashing circuit for where the flashing LEDs go. And I'm going to use this LED to isolate the flashing circuit from the rest of the lighting, as I stated earlier. Back here, for the impulse engine, we're going to have yellow, orange, and one red LED. That's going to be its own circuit in and of itself. You're going to have a warp field circuit and an impulse circuit. You can have one on at a time or both, but if you have both, the deflector dish is going to look a little funny. Now, I've set all this up to be separate circuits because that's pretty much what Lance wanted. Now, I've already shown in a previous movie that I've got enough cable coming through the tube into the engineering hall for 13 circuits and a common ground. We'll get to more of that in another video. So here we are. This is where we're at with the primary hull. We will see more of this. This is the brass etch detail work. As you can see, I've cut all of this out of the rest of the pattern that was made earlier. Spray painted everything black before I cut it out. Now what I'm going to do now is I'm going to take all of these parts, put them in the pylons in their respective places, trim off all the little tips before I do that, touch up each little corner and edge with some flat black, then super glue each one of these parts into the pylons in their respective places, and we will see this at another day or later in the video. All depends. We'll see how it turns out. Alright, I wanted to show this little project, this little work in progress. These are the parts that are going to make up the whole of a 1/2 studio scale original series dedication or commissioning plaque that I'm making for my good friend Jack to go on the base of his 1/350 original series Enterprise build-up. Woohoo! How do you like that? Is that tasty or what? Now I work on this a little bit in the evening now and then because it's little bitty tiny fiddly stuff that just makes me a nervous wreck after about 20 minutes. So I can only work on it so long at a time. But You're seeing it in its beginning stages. We will see this finished soon. Here is the circuit that I'm going to be using for the Guardian gate for both the 1/6 scale and the 1/25 scale. This is essentially the same circuit as the phaser fire indicator circuit that's going on Lance's refit, and basically a UV meter, okay? It all depends on how you set it up and how you adjust it. Now, every time the Guardian speaks, either one, you will see white, green, and blue LEDs flash behind the Guardian. So, that's what this circuit's for. This circuit is a very similar circuit, but this is going to be used inside the 1/6 scale Nomad, and it will have green, red, and orange, or green, red, and yellow LEDs. Now, I'm going to be cutting this project board in half and soldering all the components that go on this circuit here to bring down the profile of the actual circuit, make it smaller, and make it easier to fit inside the 1/6 scale Nomad. So you will see some more of this, most definitely. Alright, here's Frank's 1/25 scale Guardian gate that's going to be made into a diorama. Again, this is the circuit that's going to make all the blinkies flash in sequence with the voice files that are going to be added through a soundboard. I'll show the soundboard later. This is a piece of 80,000 styrene that I'm waiting to dry. I had to shoot it with flat white to clean it up. What I'm going to do is I'm going to put this in the sun, let it dry, then trace around this outline, cut this all out, hit it with orbital sander on both sides, shoot it with flat white again, both sides, and then while all that's drying and I'm doing that, I'm going to be adding the LEDs in here to try to get a light test done on this. I've already got the mic temporarily soldered, but I will be disconnecting that and hooking up the wire board in parallel, or hooking up the soundboard in parallel with a speaker, so I'll show that later. Okay, like I showed in the last movie last week, this has been done for a while. I just noticed, I don't know, a month or so ago that there was an area where the paint flaked off from the putty that was used to get a good finish on the seam here. So what I've had to do is take some 400 grit sandpaper, lightly sand that area where it was chipped. What I'm going to do, since it's already been decaled and everything, is I'm going to strategically mask off this area so that there won't be any lines when I reshoot that small area. Now, it's a good thing I didn't have the windows permanently put in there, because, well, it would have been a lot more difficult. Anyway, we'll see this as soon as I get this masked and touched up and repainted. All right, as you can see here, I taped off the area in question, shot it with the light gray primer. I'm going to let that set up and cure. When I peel this off, there will be a light line where the tape was. I'll take some 600 grit wet sandpaper and lightly sand down that line, let it fully dry, then reshoot it with lacquer to seal everything. Now, a note about painting. You can paint anything you want with enamel, but you can't paint lacquer or with enamel. In other words, if you have a lacquer based paint and you shoot enamel over it, you're going to have problems. However, lacquer is often used to seal decals even on an enamel surface, because you don't have the reverse reaction that you have otherwise. Now, I don't know if that makes sense or if it's clear. Just remember this. You can shoot lacquer over enamel, but you can't shoot enamel over lacquer, because you're gonna have problems, guaranteed. At any rate, we'll get back to this as soon as it's dry. Woohoo! And here we go. If you look, I don't know, you can just barely see. There's a very mild line where the tape was. So again, I'll hit that with some 600 grit wet sandpaper very lightly, then reshoot with lacquer. Alright, I got to get back onto this. I've got to put the windows in and get it ready for lighting. I've got the wiring ready to go. I've got to finish up the shuttle bay. More to come. Now we are testing the Darth Vader vocoder circuit. You are part of the Rebel Alliance and a traitor. Take it away. Now I've got to do a little work to this, but other than that, it doesn't sound too bad. Hello, hello, I love you, won't you tell me your name? Hello, I love you, wanna jump in your game? Hello, 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 hello. You are part of the Rebel Alliance and a traitor. I think that's a little too deep. See, here you've got your robot voice, your volume on the right, your pitch up and down, and your vibrato, and this sets your sensitivity. Are we having fun yet? Bow, bow. All right, I'm doing a light test here on my good buddy Scott's Darth Vader chest plate. I had to open up 3 holes on the back, or 2 holes, 2 more holes on the back of each light where the LEDs fit in, because you could only see the bright light in the center. So now you've got a much more even glow, and it'll look good. It'll look a lot better on all 3 lights. Now all I've got to do is finish up the timer sequences for 1, 2, 3, and this is in the bag. I've already shown some video, or you will see some video on the vocoder circuit I built. Now I've got to tie all this together with all the new parts. I just got in new jacks today, and get this all done and in the box and shipped out to Scott Monday. Okay, Darth Vader vocoder and chest plate. Ooh. All right, and here we have Truby Howard's 1:1 scale original series wall-mounted monitor and alert unit. Ooh. I showed this in the last movie. I would have this further along, but I can't find any clear locally that hasn't turned to amber. The 2-part clear that will replace this part, this is the actual master that I made the mold of. The clear that will take this part has to be clear, water clear, with a light surface to it, or surface texture to it. I don't know what you call it. Frost, a slight frost, sorry. My brain clutch wouldn't engage. At any rate, I've got everything but the clear and the soundboard for this, and it's almost there. Sorry, Truby, I just wanted to show you. Once again, here's the clean, crisp, clear, brand new, sharp master. The appropriate amplifier grill material, buttons, master, etc. So, now I've come up with these little spacers in here so that this will sit perfectly in there and will give you room for a speaker and lights, etc. Now I haven't placed these just yet. I will strategically place these in the proper place and maybe add a couple more. So all you've got to do is set this in there and you're done. This will be a kit. It already is a kit. I just don't sell too many because I don't have a website. Had 3 websites and they all got hacked because, what can I say? Some people just can't stand a little competition. Anyway, there you are. Okay, here's another tip. This is something I've come up with. What I'm going to do, I've got Jack's outer deflector ring here. What I'm going to do with this is I'm going to come up with a part that you can put in behind here and not interfere with the rest of the assembly. And inside that part there will be 4 neodymium magnets, north, south, east, and west, and there will be complementary neodymium magnets in the right polarity inside the engineering hall. So you will have access to the wiring through the forward section of the engineering hall in case there's ever an issue. I thought that'd be a good idea. And maybe put the flasher board in there behind all of this so that when you pull this out, or when you pull the deflector rings out, the first copper deflector ring, when you pull that out, the board and everything else will all come out with it. Fascinating, huh? And once again, here is Frank's 1/25th scale Guardian gate. Yes, it is turned the wrong way, I know. Alright, I've taken a black magic marker, I've outlined the 80 thousandths white sheet styrene. I'm going to cut that out. I'm going to put the LEDs in between this part and the clear part. I'm going to cover the clear part with a transparency that comes directly from the episode, City on the Edge of Forever. Then when the Guardian speaks from the soundboard that I will show you shortly, when the Guardian speaks, this will flash just exactly like the Guardian on the original series episode. So if we don't get to it in this movie, we will see it in the next movie. Sorry, Frank, I'm doing the best I can. Here is the soundboard for every sound-alike circuit I make. I love this little kit. I think it's great, it's awesome, fantabulous, fantastic, phenomenal. Fudge. Okay, anyway, this has 5 minutes of sound, 4 separate channels, and you can put anything you want. You will see sound effects videos later on in the film, I promise you. And you will see sound-alike circuits examples in this video as well. I'm incorporating these into all of my kits. The 350 refit build, the Dreadnought build, both 350th original series builds, the 50-inch refit build, the 1/20th scale refit bridge and BC deck, the Nomad, and both Guardian gates. So yes, I use this circuit a lot. The only difference is this time I'm going to replace that. I'm going to build this box for that speaker, and I'm going to try that speaker with an enclosed box, and if it still doesn't give me the sound I want, I'm going to take that output and put it into a different speaker, and if that still doesn't work, I'm going to run that output through a rectifier that's going to rectify the audio signal and amplify it so that it's got a longer range between bass and treble, etc. Anyway, I am going to work this out. Now, I got one of these in the works for Simon, but I haven't heard a word from Simon in a long time, so I don't know. He's so busy with his build, and I totally understand. There you go. Soundboards 101. Woohoo!
Since before your sun burned hot in space, and before your race was born, I have awaited a question. You are in error. You are a biological unit. You are imperfect.
Hello, greetings fellow modelers. This is the Iron Man helmet that I've been working on 1-to-1. As you can see, it's coming along very nicely. There are still a couple of areas that need to be cleaned up, tweaked and adjusted. But all in all, I think it's looking pretty tasty. Over here, we have the rear parts of the helmet meshed together. They need to be cleaned up with just a little bit of filler added and some final work. We also see an earpiece here, and that's just about where I'm at. I've got to finish these parts up, finish the rest of the build, and this thing is pretty much in the bag. I've still got to figure out the hinge mechanism and add some lights, but this is going to look sweet and tasty when it's all done. Anyway, that's it for part 1 of part 2.
The Final Frontier. Captain James Kirk, Starship Enterprise. Red alert, man your battle stations. Intruder alert. No, I'm a doctor, not a mechanic.